next speaker is Dr. Dan Rubenstein. He's an oculofacial plastic surgeon from UNC. So we're glad to have him with us today, and he's going to be speaking on protective lenses and other eye treatments.
Well, thanks everyone for coming, and thanks for listening. It's great to be here and talking with you. And I think we've talked a little bit about the pathophysiology, or the theorized pathophysiology for blepharospasm a number of times today. So I'm not going to review every point on this slide, but what I will say is that there's still a lot that we don't understand about why or how this disorder happens. One of the ways that we think about it was described earlier by Dr. Berman, in thinking about the natural circuitry that we have that causes reflexive blinking. So every reflex circuit in our body has an input arm or a sensory arm that we call the afferent, which detects a stimulus in the environment, and then there's an output arm called the efferent, arm, which is a motor response. That's the body's response to whatever it is that it is detecting. So we think that there's some overactivity of this circuit in the body that causes kind of overactivity of reflexive blinking. And it therefore stands to follow that if we can tone down the sensory input a little bit, we might be able to reduce the activity of the circuit overall. So when we look at the blink reflex as it relates to benign essential blepharospasm, the afferent, or that sensing arm, is the fifth cranial nerve, which is called the trigeminal nerve, and that's the main sensory nerve in the face. And that includes, its area of responsibility includes the surface of the eye. So it detects it senses on the surface of the eye. The efferent arm, or that motor arm, which is the output and the response of the reflex, goes through the seventh cranial nerve, which is the facial nerve, and that's the main motor nerve in the face. It includes innervation for the muscles that close and blink the eye. So again, overactivity of either of these arms, either the sensory component, the motor component, or both, may result in overactive blinking. When we're thinking about blepharospasm, there are two main environmental stimuli that we can think about that may drive the reflex overall. We heard a little bit earlier as well about ocular surface inflammation and irritation as they may trigger the trigeminal system. So that's great information to have heard just a few minutes ago. We're going to look a little bit more at light exposure as well in a few minutes. But interestingly, light exposure can also trigger signaling through the trigeminal system. The colored part of the eye, which is called the iris, one of its functions is to control the size of the pupil. And it turns out that there are pain receptors that are linked to the trigeminal system within the iris itself. And when the pupil constricts and the iris moves to constrict the pupil in response to bright light, those pain receptors can be triggered and signal down the trigeminal nerve. So light exposure activates the trigeminal system as well. There's a complex interplay between inflammation on the surface of the eye and photosensitivity. Again, as we were just hearing a little bit earlier, there's neurosensory components to ocular surface inflammation and dry eye that are all have complex interplays with photosensitivity as well. And we've also heard a little bit earlier that the blink reflex is plastic. Its sensitivity to environmental stimuli overall is not set in stone. The more active the reflex is, the harder it listens for stimuli in the environment, and the more sensitive it becomes to those stimuli overall. So it sets up what we call a positive feedback loop, which means that when blinking is very active, it starts to, the brain and the mechanisms within the brain that trigger the reflex start to listen harder for signals in the outside world that will trigger the reflex, and it then becomes more active and it becomes more sensitive again. So the figure here is taken from a paper that investigated the sensitivity of the blink reflex in blepharospasm patients versus control patients who did not have blepharospasm. And what it's demonstrating through muscle and nerve recordings is that patients with blepharospasm have an enhanced ability to blink in response to rapid stimuli compared to control subjects who did not have blepharospasm. So they were able to blink more frequently in response to stimuli that were applied very quickly compared to controls who did not have blepharospasm. So if we look at light exposure a little bit more, additional studies were performed where lights of varying intensity were shown directly into the eyes of subjects who have or did not have blepharospasm. And what we came to find out is that the threshold beyond which the light became very bothersome and uncomfortable is lower in patients with blepharospasm than it is in patients without blepharospasm. And in fact, when similar studies were performed on patients that have migraine headaches, it's a pretty similar threshold in patients who have migraines as it is to have blepharospasm. And that's interesting because migraine headache is another disorder which is felt to have some component of overactivity of the trigeminal nerve as well. So it's fairly similar between migraineurs and blepharospasm patients. We've also come to find out through additional studies that if we use a generalized light filtering lens that just makes the light overall coming in seem a bit dimmer, like a gray filter, you can shine a brighter light into the gray filter. And that kind of stands to reason, but it's been proven scientifically as well. So we talked about how light activates the trigeminal system, but again, the bright light may cause the iris basically to spasm as it's trying to control the size of the pupil, and that can activate that all-important trigeminal nerve. Now, in addition to the quantity of light coming in, the brightness, how strong the light coming in is, we've also found through numerous studies that some of the other qualities of the incoming light are important for triggering the trigeminal nerve. One of them is wavelength, which one way to think of wavelength and describe it is in terms of the color and the energy of the incoming light as well. So additional studies were performed where filters allowing various wavelengths and different colors of light to come through and reach the surface of the eye were held in front of patients with blepharospasm. And we came to find out that filters that would filter out light on the violet end of the spectrum, which is down below 400 nanometers, as well as in the green and yellow end of the spectrum, which is between 500 and 600 nanometers, were actually just as effective in improving light tolerance as a generalized gray filtering lens. And that's even when the light being shown through the filter was stronger than it was into the gray lens. So it's not just actually the quantity and the intensity of the incoming light, but it's the qualities and the wavelength as well. As it turns out, there's a commercially available tint called FL41, which is a rose-colored tint that has pretty similar filtration properties to the ideal that was measured in those filtration studies. And when FL41 was tested, it showed significant improvements both in objective measures that we can take, and that would include the rate of blink, the intensity of light that can be shined into the lens before blinking was triggered or before it became subjectively uncomfortable. And then when quality of life surveys were administered to the patients who were wearing the FL41 glasses, they had improved scores compared to controls, and even actually compared to gray lenses and overall light filtering lenses. So FL41, it's as effective or sometimes even, depending on the study, even more effective than just generalized dimming filters like gray lenses. All right. I'm no spectacle maven myself. I don't really prescribe a whole lot in the way of glasses just because of my specialty. But my understanding, it's readily available from most optical shops. It can be used with pretty much any kind of correction, including prismatic correction. It's effective even with relatively high visible light transmission. So even if 75% of the visible light that's coming into the lens is being transmitted through directly to the eye, it still shows a significant improvement. That would be as opposed to something like a gray lens, where the improvement threshold may be 60 or 50%, where there's a significant dimming effect. So that's helpful because it means that the lenses can be used in almost any circumstance, indoors, outdoors, day or night. It doesn't really matter that with a high visible light transmission, these can be used even in dimmer circumstances. And when we're thinking about treating benign essential blepharospasm, again, thinking about the reflex of blinking in general, we aim to put together a treatment plan that modulates both the sensory component, the incoming component, and the output or the motor component. So turning down some of the sensory input can be an effective component of an overall treatment plan. So I'll say a few words about ocular surface inflammation. We talked about it in more detail just a few minutes ago again. But ocular surface inflammation and light sensitivity go hand in hand to sensitize the trigeminal system and the blink reflex in general. So ocular surface irritation and inflammation increase the signaling generally through the trigeminal nerve, as does photosensitivity. So the two of them can be synergistic in making this reflex inappropriately sensitive. So treating them both is important to generally tone down the sensory input and turn down the activity of this reflex circuit. So to sum things up, we think one way of thinking about benign essential blepharospasm is that it's an overactivation of the natural blink reflex. The overactivity, it might come from overactivity of the sensory arm or from the motor arm on the facial nerve side of things. Light exposure is one of the components that drives the sensory or the afferent arm, and it does that by activating the trigeminal nerve. If we modify the quality of the incoming light by filtering out certain wavelengths, it's actually as effective or sometimes even more effective than just generally making the light dimmer. FL41 glasses have been proven by numerous studies to be effective for this purpose, and we really do need to consider multimodal treatment for patients with blepharospasm so that we can come at the disorder from multiple angles and have the most effective treatment. Thanks a lot.